Hi, I'm Surika Sain, course instructor for fluid mechanics. In this presentation, we will solve a problem wherein we will find out the expression for stream function and velocity potential function given the velocity components. So here is a two-dimensional incompressible flow given wherein the fluid velocity components are u equal to x minus 4y and v equal to minus y minus 4x. We need to show that velocity potential exists, and also we have to find the expression for stream function and velocity potential function. So to begin with, we will write down given data, that is the velocity component along x direction, that is u equal to x minus 4y, and velocity along y direction, that is v equal to minus y minus 4x. So with this given data, we need to show that velocity potential exists, and also we have to find out the expression for velocity potential function, that is phi, and along with it we also need to find out the equation for stream function, that is psi. So first we will prove that velocity potential exists. So to prove that velocity potential exists, we need to prove that the continuity equation is valid. So we have a continuity equation, that is dou u by dou x plus dou v by dou y equal to 0. If summation of both these terms is equal to 0, then the flow is continuous, and hence we say that velocity potential will exist. So to begin with, we will find out what is dou u by dou x. We have the expression for u equal to x minus 4y. We will differentiate this u with respect to x. So dou u by dou x will be equal to 1 into x raised to 1 minus 1 minus 0. So 1 into x raised to 1 minus 1 will be 1 into 1. So finally we get dou u by dou x equal to 1. Similarly, we will find out what is dou v by dou y. V is equal to minus y minus 4x. So we will differentiate this with respect to y. So differentiation of first term with respect to y will be minus 1 into y raised to 1 minus 1 minus 0. So minus 1 into y raised to 0 will be minus 1 into 1. So finally we get it as minus 1. Now we will add up both these terms, that is dou u by dou x is 1 and dou v by dou y is minus 1. So 1 minus 1 will be equal to 0. Hence we prove that the flow is continuous and also the velocity potential exists. Now we will find out the equation for velocity potential function. To find out expression for velocity potential function, we will use the equation which relates phi to u, because the equation for u is given in the problem. So we will use the equation which relates the given equation u and phi. So that will be u equal to minus dou phi by dou x. That will be the first equation. And second equation is v is equal to minus dou phi by dou y. And out of these two equations, we will use the one wherein the denominator is dou x to begin with. So we will use u equal to minus dou phi by dou x. Let this be equation 3. Now u is equal to x minus 4y is given. So we will substitute this value of u in the equation 3 on the left hand side. So we get it as x minus 4y equal to minus dou phi by dou x will be written as it is. And we will rewrite this equation. Dou phi by dou x is equal to minus x plus 4y. Now we will integrate equation 4 with respect to x. That is, integration of d phi is equal to integration of minus x plus 4y dx. So integration of d phi will be phi, which is equal to minus 1 into x raised to 1 plus 1 divided by 1 plus 1 plus 4yx plus c. So finally we get it as minus x square by 2 plus 4yx plus c. Let this be equation number 5. Now differentiate this equation 5 with respect to y. So dou phi by dou y is equal to dou by dou y of phi, that is minus x square by 2 plus 4yx plus c. which will be equal to, in differentiation of first term with respect to y will be 0 and differentiation of second term will be plus 4 into 1 y raised to 1 minus 1 into x plus dou c by dou y. So we get it as 4x plus dou c by dou y as equation number 6. But dou phi by dou y is equal to minus v. So we will substitute the equation of v, that is minus y minus 4x. And this we will substitute on the left hand side of the equation number 6. So we get y plus 4x is equal to, right hand side of the equation 6 will be written as it is, that is 4x plus dou c by dou y. So after rewriting equation, we get dou c by dou y as equal to y. Now we integrate equation 8 with respect to y. So integration of dc is equal to integration of y dy. So integration of dc is equal to c, which is equal to y raised to 1 plus 1 divided by 2 plus c1, which is the constant. So finally we get y square by 2 plus c1, and this will be equation number 9. Now substitute c in equation 5. So we get phi equal to minus x square by 2 plus 4yx plus y square by 2 plus c1 as the final equation for velocity potential function phi. Similarly, we will find out expression for psi, that is stream function. So to begin with, we will write down the equation which relates the velocity component which is given in the problem and psi. So the equation is minus u equal to dou psi by dou y. Let this be equation number 1, and second is v is equal to dou psi by dou x. So the steps being followed to get the expression for psi is same as that of the expression which we had derived for phi. But only the difference is that to begin with, we will use the equation which contains denominator as dou x. So in earlier equation, we had used the expression for u, but to find expression for psi, we will use the equation, that is v is equal to dou psi by dou x, because denominator is dou x over here. And the value of v, that is the equation for v, is given as minus y minus 4x. So substitute this in equation number 3 on the left hand side, and dou psi by dou x is written as it is. Let this be equation number 4. Now integrate equation 4 with respect to x. So integration of d psi is equal to integration of minus y minus 4x dx. So psi is equal to minus yx minus 4 into 1 into x raised to 1 plus 1 divided by 1 plus 1 plus constant, that is c. So finally we get minus yx minus 2x square plus c as the equation number 5. Now differentiate equation 5 with respect to y. So dou psi by dou y is equal to dou by dou y of psi, that is minus yx minus 2x square plus c, which will be equal to differentiation of first term with respect to y will be minus x, differentiation of second term will be 0, and differentiation of third term will be dou c by dou y. Let this be equation number 6. But dou psi by dou y is equal to minus u, which is given. So this is equal to minus of x minus 4y, and substitute this in equation 6 on the left hand side. So we get it as minus of x minus 4y, which will be equal to minus x plus dou c by dou y, which is the right hand side portion of the equation number 6. So after rewriting the previous equation, we will get dou c by dou y equal to 4y. Now integrate this equation 8 with respect to y. So integration of dc will be equal to integration of 4y dy. So integration of dc is c, which is equal to 4y raised to 1 plus 1 divided by 2 plus c1, which is the constant. And this will be equal to 2y square plus c1. Let this be equation number 9. Now substitute the equation for c in equation number 5 to get the final expression for psi, which is equal to minus yx minus 2x square plus 2y square plus c1. Thank you.